you may try your homework, but it is a combined 20.1 and 2. You do not need to submit it. I've made the due date Thursday, I'm fairly certain. So there's no pressure in submitting it. One big thing I want to talk about before Aaron takes over. Your calculator is stupid. Let me get this through your head. Your calculator, now, your calculator is really good at taking orders, though. So, your calculator, if you type in this, is going to follow PEMDAS. And it is going to square the 4 and then put the negative on, and it gives you the answer of negative 16. This is a lie. Here's how you fix it in your calculator. You use its problem against itself. It blindly follows order of operations, right?
No.
So, if it blindly follows order of operations, if you're holding a calculator, try this now. Put your negative 4 in parentheses, and then square it. And now, you'll get the correct 16.
I got negative 16.
And you didn't type it in right. Now, your square has to be outside the parentheses. Yeah, because it has to do parentheses, then do square. So, be very careful. Here's the other way to avoid that. Turn on your brain. A negative times a negative is a positive. We know that. So a negative squared is gonna be positive.
A negative
So,
cube is going to be negative.
well, we're not there yet, but yes. So, hey guys. So Aaron's taking over. He's got like a little over 10 minutes to drop some knowledge on you guys. Please give him more respect than you give me, which today has not been very much. So please simmer down. Pay attention to Aaron. He's already in high school math 3, so he's got some knowledge to drop on you guys. So some of these guys might know what a perfect square is, so you can't ask. I don't know if they know or not.
Does anyone know what a perfect square is?
No.
A perfect square is a number which the square root of is a whole number.
What?
There's an easier way to define it. You're right, but there's an easier way.
Okay, yeah, I don't know how to explain it.
A perfect square is just a number multiplied by itself. That's the one that
Well, it's the result of a number multiplied by itself. So it's really easy. Aaron's going to do it on the smartboard, but I'll do it on the chalkboard. To make lists of perfect squares, which last year somebody tried to fill up a page of graph paper with.
I did that.
What's 1 times 1?
1,
2 times 2?
4,
3 times 3?
9,
4 times 4?
16.
Start listing these on your paper, please. So we have a few of them listed out. So we've got 1, 4, 9, 16, 25. All right, Aaron, take over. I'm going to just keep writing perfect squares.
Okay.
Next
Is
guys.
of a number. It's where you do the opposite of getting a perfect square, and you go back to the original number.
How do you do
There's a
that?
lot of perfect
You take the result and then divide it by its
This is the reverse of a
How? Like, how do
So
you
where it comes from, where square root actually comes from, like we talked about this morning with the square. So that's off to the right here, the relationship between squares and square roots. So that's kind of what you want to show there. Make it easy. Make it like an area of 9 or something like that.
So with like square roots, the square root is the inverse of squaring a number. So if you do 3 squared, you get 9. But to do the opposite of that, you just take the square root, which would be the square root of 3. Or square, my bad. Square root of 9 is 3.
how do you manually do square roots without the calculator button?
With perfect squares, it's really easy because it's just with perfect squares, they're really easy to memorize. So like 4, 9, you'll just remember those ones really easy. But with other numbers that aren't perfect squares, it can depend on what math you're in. Yeah.
So where this comes from is so the name square root literally means the root of the square. So what we're talking about conceptually, and I'm just going to use the chalkboard, who cares if it's on the smartboard, is if we have a square of value, so area, 9, what is its root or edge value?
3.
So we're saying what length, when made into a square, results in an area, bless you, of 9. So that here is 3. Now this gets very hard. If we have something like 10. Because then we're saying some number times itself, if these are my e's, will equal 10, and well, 3 times 3 equals 9, and 4 times 4 equals 16, so there's some number between 3 and 4 that will make 10 when multiplied by itself. We don't need to deal with that yet. We are only dealing with perfect squares right now. I do not expect you to be able to deal with non-perfect squares. That is a Math 8 topic that we don't get into this year. This is a Math 8 topic. We're just not going that deep into it. So we only need to care about perfect squares. If you would like, you may download or you may write out your own list of perfect squares. I went all the way up to 225 over there, which is 15 squared. If you memorize those and not take time to memorize, but just use them over and over and you just get used to them, up to 15 squared is pretty safe. We don't normally work with too many squares above 15 squared. So we've got 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, and all the way, it just keeps going.
But those are also negatives, but you guys won't deal with those as much because doing square roots, you can also have a negative number be so if you want 4, it can be 2 or negative 2 because you can do the square root and you'll get the same answer. But you guys won't have to deal with the negatives as much.
So that's getting deeper into the concept. So the concept of square roots is a number times itself. Where it came from is the physical, right? We have a square, it's got an edge length. Well, this length can't be negative. But conceptually, if I say a number times itself makes 9, I can use 3. Or I could use negative 3. So conceptually, we can use the positive or the negative. Physically, tangibly, we normally only care about the positives. On your homework, all you care about are the positive answers. So if it says, what's the square root of 9? Your answer is 3. In reality, it's positive or negative 3. You don't need to worry about that yet. Okay? Anish?
I don't understand. If I put 2 to the power of 0, I don't understand. Shouldn't it be 0?
So that's actually lesson 5.5. You're getting ahead of us. But what that is saying, so powers. Powers are how many times you repeat multiplication. So you're saying 2 to the 0 power. Well, let's first talk about what if we have 2 to the second, and you don't have to write this down. That's saying 2 times itself so that there are 2 of them. This is saying 2 times itself so that there are none of them. Now that's weird, right? So how can I have something times itself so that there are none of them when I get done? Well, there's always actually, if we think about x squared, how many x's are there?
2.
Well, so there's x times x, but if I only think about x, how many x's are there?
1.
Do I need to put a 1 here to know that there's 1x?
No.
No, we just know this is 1x, and then when I square it, I have 1 times x times 1 times x. This is really 1, 2 times another 1, 2. So this becomes 1,
already
works.
works.
We're done. I did like that. That's where that comes from. It's 1 times this 2 that doesn't exist because they said you want none of them. So any, and this is way further than you need to care today. This won't show up on your homework till 20.5. Any value to a 0 power is 1. Any, no, like positive, negative, whatever. Any number to the 0 power is 1.
So 1 to the 0th power.
Because you're saying multiply 1 times itself, so there are no base values. Because this is called your base, and this is your power. So we're saying there's going to result no bases, but we still had numbers to start. We still had a 1 of this happening.
But in 1 to the power of 0, if the answer is 1, then you still have 1.
Right, but that 1 doesn't count because that 1 was how many. Like you had 1, 1 to start, and then you took that 1, 1 that you had to the 0 power. That 1, 1, the second one, we're getting really deep conceptually, it doesn't make sense. That 1, 1 to the 0 power, this now disappears, and we still have this 1. It is very complicated. I didn't want to go this far today. It didn't. So, let's get a bit of understanding so you might be able to do your homework. I'm going to sit down.
Stop asking deep questions.
You're too far. Go look at the Schoology page. I've updated a bunch of stuff. Focus on Aaron.
Okay, so for this one, when you have 9, you're trying to figure out what the square root is. So it's the same with this. So what you would do is you take the inverse of x squared. You put a radicand over the 2x squared and over the 4, and then you get x equals 2 because the root of 4 is 2. So that would be your answer.
Wait, so define the
So
number.
another way we can think about this. He's showing the how to solve. One of the issues is Aaron's stuck in like, here's how I do math, not how I teach math, which is why Aaron's here, right? He's learning how do I teach math as opposed to do math. What x squared is saying, think about question A, not B. X squared is x times itself. So we see a number times itself equals 4. So what I need to make that 4 is into something times itself, which I know, well, that's really 2 times 2. So my x must be 2, since that's the number times itself.
So the
that
square
makes 4.
root of 4 is equal
Is
to
2.
x.
Well, it's 4 now, but yes.
But in this case, yes, because you have x squared, and it's basically saying x is equal to 2, but x just got squared, so you have to do the same as 2, and you get 4, and you're just trying to go backwards.
So remember, this is just like solving equations, but we're diving in very heavy because you already know how to solve equations. We use inverse operations. Here's another trick that I forget if I put on the first homework. Forget if I put this on the first homework, but if we have x squared, and we want to undo something being squared, we just square root it. I would put this on your notes somewhere. To get x by itself, a square root cancels a squared, which is what Aaron was showing up here, because what he did was he did the square root of 3 squared, because 3 squared is 9, and that comes out to be the original 3. So square roots and squares are inverses, just like multiplication division.
So if you don't know the square and you only know the square root, then you need to.
I think your understanding isn't quite far enough to be asking the questions that you're asking, because you're not using the words correctly. So the root is the value, the answer, like the edge length of the square. The square is the area when we have a certain edge
I thought, 4
length.
was the square root.
Well, it could be if my square was 16. So 4 is a fun value that is a perfect square and also a perfect square root, depending on how it's used. Because, and then I'm going to release you guys because we've gone kind of way off tangent. 2 squared is 4, but the square roots of 16 is 4. Here it is the square. Here it is the square root.
If you've ever done like a factor tree, it's that simplified to like one step.
Oh,
So just take that as your tiny taste. You can try the homework if you want, but you really don't need to. We will cover both 20.1 and 20.2 tomorrow. Thank you guys. Have a good day.
What's wrong with